During flight operations of an airline, there are certain operations which are very special, and in the series of talks about these special operations, let us look today about what is called as polar operations. The content for this presentation was created by Soumya Saravagi, who was a summer intern with me, and at that time she was a student of NIT Durgapur. So these are polar operations. Basically, when you fly in the area near the poles, so if you look at the North Pole, if you fly near the polar area, in the area north of 78 north latitude. So this area, for example, this is the area where if you fly in this area, now I don't mean flying only within this area. What I mean is any flight that actually covers this area, that can be considered as a polar route. Now this area, you can notice, is on the north of Alaska, and also it is also north of a large part of Siberia, which means it's a very, very cold region. You also have flights in the south polar area, which would be in the area south of the 60° south latitude, which would be inside this. So any flights inside this, or any flight that covers any destination, any route within this, can be called as the south polar route. These operations are also called as high latitude operations because they occur at the higher values of both north and the south latitude. The first flight over North Pole was done way back in 1926 by Richard Baird and Floyd Bennett from Spitsbergen in Norway. It was an adventurous flight, and it went for nearly 15 hours. And it was driven by basically curiosity. So from Spitsbergen they took off, went a little bit north of the North Pole and came back and landed. There has always been a curiosity in the minds of people on how the landscape looks. So with that in mind, a chartered plane with around 230 passengers was flown from Berlin to the North Pole and back by an Airbus A330-200. Okay. It was just a sightseeing flight which flew over Greenland, Norway and Spitsbergen. And interestingly, as you go near the North Pole, all the time zones of the world are merging. So this flight crossed all the 24 time zones over the North Pole. But the question that arises in our mind is, why are we worried about polar operations? Why do we want to fly over the poles? So this is the route which is normally taken by the aircraft, bypassing the North Pole. This is a longer route, and there can be a shorter route between these 2 points which provides the shortest distance. Polar operations allow non-stop routes which were not existing earlier because of the savings in the distance and the time. This also results in an increased choice as convenience, reduces the trip time, and also it avoids the crowded hubs on which all the aircraft normally fly. Polar operations also allow higher operational efficiency because you are spending less on fuel, you have shorter trip distances, and therefore you have a higher payload potential between the 2 points as shown in the screen. Also, it may be possible to eliminate a stop for fueling which might be needed in very long routes on non-polar routes, right. So, you can see, look at for example, flight from Chicago to Tokyo. Presently, this flight actually takes this particular route. Okay. Whereas, if you have the ability to fly on a polar route, it would actually go straight, from here to here. Similarly, there are so many other flights which I have to go via in a rounded fashion, but which could have been possible much shorter route if we were able to have polar routes. Another example is London to Tokyo flight, which currently you can see has to go in this fashion, whereas it can go in a straight fashion in case we are allowing polar routes, in case we are allowed to enter this area of the operations in polar routes. Air India also was one of the airlines that experimented with a flight from Delhi to San Francisco. This was on the Independence Day of 2019, flight AI 173 on a Boeing 777. It flew over the polar region, and this was the first Indian commercial flight to go over North Pole or near North Pole, and after that there will be many other flights also. This flight took approximately 15 hours, but if we go by the normal route, then you can see that you need an additional 1 hour and 45 minutes. So, therefore, you save approximately 2 to 7 tons of fuel, and therefore, the carbon dioxide emissions are also reducing by a large amount. But it is not very straightforward to fly over Santa's home. You need to do a lot of preparations and planning. And the next question that everybody normally has is that if polar routes are so beneficial, then why not always fly over the polar routes? Why do we have to follow, in most cases, a circuitous flight path avoiding the polar region? What is the problem? So, we will look at that. If you want to fly over the polar routes, you have to be very careful to look at the regulatory requirements. Okay? You have to look at various en route alternatives such as the Anchorage Airport in Alaska. You should have a clear-cut recovery plan for passengers. In case you have to land in a cold area, there should be enough equipment available to support the passengers. Communication channels are little bit difficult over the polar route, as we will see in more detail. So, one has to make preparations in that direction. Similarly, the navigational environment also has to be unique, because what we normally follow is the magnetic heading that becomes useless near the poles. It gets completely confused. We have to invest a lot of money as well as effort in training and providing the requisite equipment to allow polar routes. There has to be management of the cold fuel, because you will be exposed to very, very low temperatures. Anti-exposure suits have to be worn. Cold temperature altitude correction procedures have to be followed. Then the exposure to the radiation is much larger than what you have in the equatorial region, and that high exposure is there for a very small time. So, the body takes a lot of time to get acclimatized to it, and then, as I said, you have to learn about how to manage the cold fuel. So, there is generally a minimum equipment list or MEL for polar operations. So, a fuel quantity indicating system or FQIS has to be incorporated, which not only indicates the quantity but also tells you the temperature of the fuel tank. Because if the temperature is going to fall very low, the fuel may freeze, and that can cause a problem with the supply to the engine. So you need to probably come to a lower altitude or go to a hotter area. The auxiliary power unit installed in the aircraft has to be specially equipped. It should include electrical and pneumatic supply to its design capability, because it will be required to a large extent when we use the aircraft over polar routes. Then there has to be an auto throttle system in the aircraft, plus the communication systems which are relied on by the flight crew members. They have to be tested and ensured that they satisfy the requirement for the communication capability that you will need. And then the flight management system or FMS also needs proper guidance. Okay. So we will now look at the key issues in operating polar routes, which is one reason why many airlines would not like to go in this direction despite the obvious advantages of less distance, less fuel. Fuel freezing is one problem, communication is the other, navigation is the third, solar radiation can be a problem, and finally lack of alternate airports along the flight path. Let us look at fuel freezing. Fuel freeze becomes an issue when the temperature of the ambient air drops below 65 degrees Celsius. But fuel freezing should not be confused with freezing of the dissolved water in the fuel. Even if you have pure fuel without any contamination or without any water, it will still have a problem of freezing when you reach very, very low temperatures. This chart indicates the average freezing point of fuel in centigrade at various airports. Most of them are in the Northern American region. And we also have the range of the freezing points. So the temperature of the fuel falls to just about 3 degrees above the temperature at which the fuel freezes. So the margin available for you is very less, just a 3-degree margin. If for some reason the temperature goes further down by 3 degrees, the fuel will freeze. So to tackle this problem, you may have to change your flight plan to move in an area where the air is warmer, or you may have to descend or ascend to fly at a particular altitude. The other way is to increase the speed of the aircraft to create the aerodynamic heating. All of these steps are going to lead to increased fuel consumption. So whatever benefits you are going to get by flying over polar routes, some benefits might have to be compromised because of these factors. Then we have communication issues. So this graph shows the types of communications which are working and available in the polar routes. So you can see that the red line indicates the availability of VHF communication, the orange line indicates the HF communication, and the white circle indicates that in this area you will be able to depend on the SATCOM. Okay. SATCOM will be useful in this area, and you can notice the dotted lines indicate the various polar routes which are being introduced. So in sum, both VHF and HF equipment are needed for communication purposes when you fly polar routes, and in this area marked as a circle above the 82° north latitude, that area you will not get communication, reliable communication using VHF and HF. So you will have to have SATCOM as a backup, right? And remember that before you enter the polar regions, you need to have detailed and current updates about the weather and the en route alternative airports, because you will be flying for many hours without reliable communication. Then there are some issues related to navigation. The mainstay of navigation for aviation happens to be the compass, and that is not available or highly unreliable when you operate near the poles. Then this is mainly because there is a convergence of all the meridians and they cause issues. You will get very large heading errors even for small errors in locating the aircraft position. And the inertial and GPS based FMS systems are referenced to the true north and not to the magnetic north using the satellites. So for example, many aircraft are designed to use some dedicated protocols. For example, the 747-400 and the Boeing 777, both from the Boeing stable, they use what is called as lateral navigation using GNSS and INS together to cater to this particular problem of poor navigation in the polar regions. Then we have the issue of solar radiation. So as you increase your latitude, the radiation of sun also increases because the magnetic shielding reduces. Okay. So at some polar regions, the radiation would be twice compared to what we experience in the equatorial regions. Okay. So during solar storm, the exposure of the aircraft and the manpower to the 12% of the recommended limit is only permitted. Exposure is high at high altitudes where the atmospheric protection is lost. So if you are high and if you are also at the higher latitudes, you are going to have a lot of solar radiation. In fact, it is so large that the people who are operating in this environment, they are called as radiation workers, similar to those who operate in the nuclear facilities or similar facilities where there is a large amount of radiation. The solar radiation is going to affect the HF communication, which is the only long distance communication means available. It will make the quality very poor, it will create more noise and fading, and you have to shift to lower usable frequency bands because of the problem of solar radiation. Moving ahead, we also have very limited alternate airports when you operate in polar regions, because there are not many alternatives available with paved runways for large aircraft. Then there is no regular airline service or custom service at these airports. Most of them are military airports or dedicated for local communities. So you can notice that these are some of the established airports: Baro, Pevek in Russia, Khatanga, Murmansk. Then in Norway we have Bodo, Longyear, NOR, Thule in Greenland. These are some of the airports which might be considered as alternate, but there are very few, and there is none in the center of the area of operation. Looking back little bit about how we started looking at the polar routes and why we had this issue right from the beginning. So during the Cold War, the Arctic region was a buffer zone between the Soviet Union, shown in the red color here, and the North America, shown in the blue color here. So between these two was the Arctic region, which was a buffer zone. So nobody used to permit flights in that area. So before 1990s, the Soviet aligned countries, they were restricting their airspace for countries in the other sector or aligned to the US. So therefore, these countries, they had to follow longer routes. The area that is shown in the dark color on the right hand side in this graph or in this figure is prohibited airspace by Soviet Union and the countries which were allied to Soviet Union. So, the routes were then not available to the rest of the world, and that is why that area was a no-fly zone. So, in 1998, Russia gave permission to operate 4 polar routes. Just 4 polar routes were permitted. And then slowly and slowly more and more routes were started. So, these are the 4 polar routes which were permitted by Russia. So, they begin and end in the Russian FIR, Flight Information Region. Okay, the 4 yellow routes are the new polar routes. There were some crossover routes earlier and then there were conventional routes, but the polar routes for the first time. Now, none of these civil polar routes, they are operating within 60 nautical miles of the North Pole, because at the North Pole exactly things are going to become very difficult for you. So, mostly the polar routes are the ones that operate about 60 nautical miles from the North Pole. Now, we forgot that we also have a South Pole, and why not look at South Pole also as one of the possible routes to fly. So, why not Antarctica? So, the constraint that comes from there is because of the ETOPS, the extended range twin engine operations. So, if you have ETOPS 330 permission, that means if you can fly with an alternative airport within 330 minutes, okay, 6.5 hours of flight time, then it is possible for you to fly over Antarctica, but no airline has scheduled any flights. This is the area with ETOPS 370. Okay. So, Sydney to Cape Town route can be operated if you have ETOPS 370 clearance. Similarly, Sydney to Rio de Janeiro route. But if you have ETOPS 330, then you have a larger area. So, Auckland to Buenos Aires is one possibility that opens up, similarly Sydney to San Diego. The problem is that there should be enough market over these routes, right? The airlines can operate, but they don't exist. Okay. Why? Because of the problem of infrastructure. There is hardly any infrastructure available in that area. There are no resources available in that area. There are frequent whiteouts, and in case there is an incident or a crash, then the survivors are going to die because of cold more than anything else. It will be almost impossible to actually reach the survivors to save them. But some airlines have definitely come close. So, the most popular route which goes near the Antarctica, or the southerly polar route we can call it, is Sydney to San Diego in Chile. This is the most southerly polar route which is currently being operated, right. Then there are some charter airlines which conduct flight to Antarctica only for sightseeing. So, you are not landing, there is no destination, you just go up in the air and people have a view from the sky. Okay. Now, there have been cases where there have been crashes, and this crash, for example, killed 257 passengers and crew members when it hit Mount Erebus in the Antarctica. So, there have been such instances also, which also might deter many people from operating regular routes over the South Pole. Now, the Arctic is melting because of global warming, whether we believe it or not, it is a fact, right. So, there is an increase in popularity. There were around 50,000 flights per annum by 2010. Now, cross-polar flights are a large source of black carbon pollution because that area is highly unpolluted right now, and if you fly regularly on that route, you are creating pollution in an area which is currently unpolluted. Then diverting all polar routes. When you have polar routes, diversion becomes a serious problem because of the cost, because of the greenhouse emission warming the entire planet, and you need to have a trade-off. It's not straightforward. The trade-off will require you to balance the financial improvements and the time reduction with the cost to the planet in the form of pollution. Thank you for your attention.